AI can write a trading strategy in seconds, but can it follow your exact rules, or will you spend more time fixing the AI than building the strategy? To test that, I'm comparing 3 of them: OpenAI Codex, Gemini, and Claude Code. I wanted to do this because I've tried a lot of AI tools for trading strategy code, and the gap is usually the same. In demos, it looks simple. You describe your idea, the AI writes the code, and the strategy works. But in real life, you still end up fixing syntax, re-explaining the logic, changing prompts, and checking whether the backtest actually matches what you asked for. Sometimes that takes longer than writing it manually. So I gave all 3 agents the same task: build a SPY moving average strategy, run the backtest, optimize it, run a walk-forward test, and create the charts. I'm not looking for the nicest chat answer. I'm looking for the one that gets the work done fastest, with the fewest fixes. First up is OpenAI Codex, and I'm using the GPT 5.5 version with the speed set to fast. I give it the strategy requirements. Buy SPY when the 20-day moving average crosses above the 50-day, only when price is above the 200-day trend filter, and exit when the 50-day moving average crosses back above the 20-day. Codex thinks for a bit, then immediately turns that into an implementation plan. It checks the local files, confirms the data source, and starts creating the RealTest script. It opens the NOR gate data and imports the symbols. I speed it up a little bit here because the larger GPT versions take longer to think. So, the Codex runs the test and produces the first result. It shows me the final equity curve chart. I also open it inside my own RealTest setup to make sure everything works on my side too. And yes, it looks good. Now I move to the second round, optimization. I ask it to test different moving average lengths, instead of assuming 20, 50, and 200 are automatically the best settings. I test this because a single backtest can be misleading. Optimization shows whether the idea is robust across nearby parameter values, or whether the result only works because one lucky combination was selected. Codex builds the optimizer grid and runs the command line optimization. The heat map appears, showing MAR across different fast and slow moving average periods. The useful thing here is not just the highest number, the useful thing is the shape of the grid. If good results only exist in one tiny corner, the strategy may be fragile. If good results appear across a wider area, the logic is more stable. For round 3, I ask for walk-forward optimization. Now the AI has to optimize on one historical window, then test the selected parameters on unseen future data. That helps separate curve fitting from actual forward generalization. Codex creates a chart showing the in-sample and out-of-sample equity curves, and once again I check it inside my own RealTest setup. Looks good. Next is Gemini inside anti-gravity. I am using Gemini 3.1 Pro version. Same task, same RealTest environment, same idea. I'm looking for whether it can follow the same path. Write the script, run the backtest, optimize, and produce charts. Gemini starts by inspecting the local strategy language and then generates the files directly in the project. Gemini creates the RealTest script, and if it's done, it's showing me the final equity curve too. Now I test the optimization. It tests the fast-moving average, slow-moving average, and long-term trend filter. The key constraint is that the fast-moving average must be shorter than the slow-moving average. Otherwise, the strategy logic becomes invalid. Gemini catches that and builds the optimizer around valid combinations. The heat map shows the optimization result. Again, I'm not only looking for the brightest square. A strong coding agent should not just return the winning parameter, it should help me understand if the winning area is stable, clustered, or suspiciously isolated. Gemini then handles the walk-forward test. This is the more realistic version of the experiment. Optimize on past data, then apply those parameters forward. The resulting chart compares in-sample performance against out-of-sample performance. The out-of-sample curve is lower, which is exactly why walk-forward testing exists. It exposes the gap between optimized history and future-like performance. And inside the RealTest, everything works well. Now I switch to Claude Code. I'm using the Opus 4.7 version, same task again. This keeps the comparison clean. One strategy, one environment, 3 agents. Claude starts with the same base strategy. Claude is reading the files and imports the data, runs the backtest, and generates the first equity curve. The chart shows our strategy equity curve, and inside the RealTest looks good. Next is optimization. Claude is using my optimization skill, and it runs the parameter grid and creates a heat map, similar to the previous agents. This step is important because strategy code by itself is cheap. The real value is whether the agent can run the research loop, code, test, inspect, adjust, and visualize. And finally, Claude builds the walk-forward version. It writes the rolling parameter selections into the script, runs the optimizer pass, then runs the separate backtest pass using those walk-forward results. This is the most important part of the benchmark because it tests whether the AI can manage a multi-step research process, not just write a single file. The final walk-forward chart shows the difference between optimized in-sample performance and out-of-sample performance. After testing all 3, my winner was Claude Code. Codex and Gemini both did useful work, but Claude Code was faster, smoother, and more reliable through the full process. And that's why I built the new Setup Alpha course around Claude Code and RealTest. The course gives you the RealTest files and workflow I use so Claude Code can plan a strategy, write the script, check and fix errors automatically, run tests, and help decide whether the idea is worth more research. One module also shows how Claude Code run the backtest and create the Notion research report automatically. You can start the work, go for a walk, and same time check your phone to see what was tested, the results and whether the strategy is worth continuing. AI will not replace your judgment as a trader, but it can help you test faster, spot issues you may not have thought to check, and avoid wasting time on backtests that only look good after too much tuning. The course link is in the description. On the course page, you can see exactly what is included and how the workflow works. If you've tried using AI with RealTest before and felt like it wasted more time than it saved, this course was built for that exact problem.